Hello friends, today I will discuss about the data model, data abstraction and data independence in this lecture. So basically this is fifth lecture of unit 1 which we have started some day ago. That is introduction to database and transaction. So today we will discuss three topics only, that is data models, data abstraction and data independence. So when we discuss about the data model, so basically whenever you are going to work with database management system, so there are some particular rules which you have to follow when we are going to select any data models. Because as we know, in the last lecture I have already discussed, I have discussed 10 to 12 types of data management system. So every data management system have their functionality, advantage and disadvantage. So data model is basically a things which we decide when you are going to design your database management system, because it totally depend upon how you have to store the data, how your data is going to be stored, and which type of operation you are going to perform with your database. So there are many things which you have to keep in mind to selecting your data model. So nowadays, if you're talking about nowadays, so mostly relational data model is used. And when you are talking about relational model, means the model where your data is stored in a tabular format. Okay. So basically, a database model defines the logical design and structure of a database and defines how data will be stored, accessed, and updated in data management system. And data model is the modeling of data description, data semantics, and consistency constant of a data. And also is provide the uh, cons- conceptual tools for describing the design of a database at each level of data abstraction. So in next slides, in after some slide, also we discuss what is data abstraction. So basically, data abstraction means to hide unwanted thing from the user, or you can say unwanted detail from the user. So there are various data model being used nowadays, but the relational data model is the most widely used model. So the data model is used to describe the way information is stored and retrieved from the database, and it's also define the rules by which the database will be operate. So also we can say a data model can be defined as an integrated collection of concept describing and manipulating data, as well as constraint on the data within an organization. So a data model is just not just like a set of table, it is a conceptual representation of physical data stored in the database. So now when you are going to design a data model, so there are some things which you have to keep in your mind. The first step in designing a data model is to define what kind of data you want to store in your database. So this is usually involves defining the entities involved in your application, and if we're talking about what is entities, suppose I am talking about a student just like a entity. If there is a teacher, teacher is just a entity. So an entity is any object that exists independently of anything else. So you might think about entity as something like a person or a address. Okay, so once you are find out all the entities, you need to decide how they relate to each other. Means here we are talking how data are connected or related to each other. The next step is to figure out how those entities will interact with each other. Firstly, we have to decide which type of data you want to store in database. Again, you have to find out all the entities. Okay, and also you need to decide how they relate to each other. The next step is to figure out how those entities will interact with each other. So in some application, you may want to create a single table to hold all the data about a particular entity. So also you can create several table to store the data, and where each table hold only part of a data about an individual entity. In addition, you should consider whether you need to perform queries across more than one table. If so, we'll probably need to link them together using foreign key columns. So as we already discussed, there are two key. One is primary key and foreign key. So these key used to create a relation between the table. So once you know the basic structure of your data model, you can start thinking about how best to organize it into table. So there are two main approaches. So relational databases and hierarchical databases. Relational databases are organized around a set of table that share common field, and hierarchical databases are organized around a tree-like structure called a hierarchy. Okay, so now why we use data model? So basically, data model are extremely useful for any organization as they let business users directly define core business rules. As a result, fewer revision are required during the implementation. It's also lead to significant reduction in development time, allowing businesses to deliver new businesses and project faster. So basically, data model is just related to database and how you are going to store the data, because when you're talking about big organization which they are working on data, so defining data model is matter most. And when you're talking about what is advantage of using data model, so uh, helps to cut out cost and deliver product faster. It's improve business process significantly, reduces complexity and risk in data handling. Now we're talking about types of data models. So there are various data model. Here you can see we have network model, relational model, hierarchical model, object relational model, semi-structural model, entity relationship model, object-oriented model, and associative data model. So in this lecture, we discuss one by one. Just I am taking overview because in detail we have already discussed in our last lecture. Okay. So now talking about hierarchical model. So in this picture, you can see there is a tree-like structure. So this database model organizes data into a tree-like structure with a single root, and to which all the other data is linked, and the hierarchy start from the root data and expand like a tree, adding child nodes to parents node. So here you can see in this picture we can say college is a root, and department infrastructure we can say the parents, and also here you can see under the department there are course teachers and students, these are child nodes, and under the course here you can see the theory and labs, so these are uh, grandchild node. Okay. So in this model, a child node will only have a single parents node. So one parent can have multiple child. Oh, okay. One parent can have multiple child, one multiple child, and each child will have only one parents. Okay. Now, features of hierarchical model. So one to many relationship means the data here is organized in a tree-like structure where the one to many relationship is between the data types, and also there can be only one path from the parent to any node. And talking about parent-child relationships, so each child node has a parent node, but a parent node can have more than one child node. Okay, so multiple parents are not allowed in hierarchical model. So if a parent node is deleted, then the child node is automatically deleted. And basically in the hierarchical model, pointers are used to link the parents node with the child node and are used to navigate between the stored data. And the last structures we have already discussed. If you want to access data in hierarchical model, So there is a predefined path for assessing data. You have to follow that predefined path to assess the data. Talking about advantage, so it is very simple and fast to transfers through a tree-like structure, and any changes in parent node is automatically reflected in the child node. So the integrated type data is maintained. Or when you discuss about the disadvantage of hierarchical model, so complex relationship are not supported, and as it does not support more than one parent of the one child node. So if we have some complex relationship where the child node needs to have two parent node, then that cannot be represented using this model. And if a parent node is deleted, then child node is automatically deleted. So these are some disadvantage of this hierarchical model. And now next one is network model. So basically this is an extension of hierarchical model. In this model, data is organized, more like a graph, and are allowed to have more than one parents. And this database model, you know, used to map many to many data science relationship. And this was the most widely used database model before the relation model was introduced. So here you can see, suppose this is a student. If you want to assess a student, so here you can find various paths. By using this also you can assess, by using also this can assess. So basically there is no any predefined path, any path you can follow. Here you can see, if you want to send transaction, so here, okay, from here also you can assess, from here also you can assess, from here also can access. So there is multiple paths possible in network model. So when talking about advantage of network model, so the data can be accessed faster as compared to hierarchical model. Reason is that there are multiple paths possible in network model. In hierarchical, there is a predefined path, but here there is no any predefined path. So whatever shortest path available, you can access data through that path. So this is because the data is more related in network model, and there can be more than one path to reach a particular node. Okay, there is a possibility of more than one path. That is main reason you can access data more faster in network model compared to hierarchical model. As there is a parent-child relationship, so data integrity is present, as any change in parent record is reflected in child record. So this is same as like hierarchical. And talking about disadvantage of this model, so as more and more relationship need to be handled, the system might get complex. So a user must having detailed knowledge of the model to work with this model. And in this, any changes like updation, deletion, and insertion is very complex. Now talking about relational data model, so in this type of data model, your data is stored in form of rows and column. And basically this model is used to store data in a tabular format. And this relational data model is widely used model, which is primarily used by commercial data processing application. So nowadays mostly company use this type of relational data model. So here you can see your data is stored in a table like structure. This is column, and this is record. So basically this is example of relational data model. So this is very simpler as compared to network and hierarchical models, and this model can be easily scaled, as we can add many rows and column as we want. And we can make changes in database structure without changing the way to access the data. When we can make changes to the database structure without affecting the capability device, so data we can say that is structural independence has been achieved. So basically, in next slide also we will discuss data abstraction and data independence. So in that case we will discuss what is meaning of data independence. Data independence means we can change any layer without affecting the other layer. So this is possible in relational data model. Now talking about disadvantage of relational data model. So basically, so for hiding the complex complexities and making things easier for a user, this model require more powerful hardware, computer, and data storage device. And also we can say, as the relational model is very easy to design and use, so user don't need to know how the data is stored in order to access it. This age of the design can lead to the development of a poor database, which would slow down if the database grow. Now talking about entity relationship data model. So basically entity represent a thing, we can say. So entity relationship model, or simply ER model, is high level data model diagram. And in this model we represent the real world problem in the pictorial form to make it easy for the stakeholder to understand. And it is also very easy for developer to understand this system, but just by looking the ER diagram. By looking at the ER diagram, a developer can understand what this picture want to tell, means what we are going to do. So basically, we use ER diagram as a visual tool to represent an ER model, and there are three things in the ER model. One is entities, second is attributes, and third is relationship. So entity is a real world thing. It can be a person, place, or even a concept, as like a teacher, student, course, building. Basically these are example of entities. And an entity contains a real world property called attributes, as like if I am talking about teacher, so teacher will have a name, will have a age. Okay, so this is will have a salary. So this is example of attributes, or means properties of that particular things. Now relationship, so a relationship tell how two attributes are related to each other, means teacher works for a department, so there is a relation. So in this picture you can see this is a pictorial diagram of ER, how ER is going to be presented. So here you can see teacher is an entity, and these are some property of teacher. Okay, so these are attributes, and this is entity, and this is basically relationship. How teacher related to this department. So here also you can see these are attributes, and this is entity, and this is relationship. Basically this is a way of representation of ER model. So in circle we represent attributes, in rectangle we represents entity, in diagonal we represent relationship. Now simple, this is very much simple, and also this is effective communication tool and easy conversion to any model. Now what are disadvantage of ER model? One is no industry standard for notation. Basically it's totally depend upon the DBA, we can say, okay, how and which type notation they are going to use, because there is no any particular standard notification or notation by which you have to design your ER diagram. So there is no industry standard for developing an ER model. So one developer might use notation which are not understood by other developer. Okay, and some information might be lost or hidden in the ER model, as it is high level view. So there are chances that some detail of information might be hidden. So now next one is object oriented data model. So the real world problems are more closely represented through the object oriented model, and in this model both the data and relationship are present in a single structure known as a object. So we have already discussed in this type of data model. Basically, your data is stored in the form of class and objects, and we can store audio, video, images in the database, which are not possible in the relational model. Okay, and although you can store nowadays because they have developed so much functionality or data type, we can say now in relational data model also we can store, but earlier we used to use object oriented data model to store audio, video, something like this. So basically this is structure of object oriented data model. Here you can see employee and attributes, and method is get hired, change the number, here equal c. So object oriented data model excel at the representing real world entity as in their relationship, and nowadays it is very complex to use, and disadvantage is that there is a very limited adoption of object oriented object data model nowadays. So now talking about object relation data model, so as we know by name also we can see this is combination of object oriented data model plus relational data model. So this model was built to fill the gap between the object oriented model and the relational model, and we can have many advanced features like we can make complex data type according to our requirement using existing data type. And the problem with this model is that this can get complex and difficult to handle. So proper understanding of this model is required. And currently we have no such idea about this model. Now talking about semi-structured data model. So a semi-structured model is modified version of relational model, allowing for the greater flexibility in representing data. It is impossible to differentiate between the schema and data in this model because this model is based on the assumption that certain entity might have attributes that are missing. So in constant, other entities may include an additional attributes. So here you can say take example to understand what is meaning of semi-structured data model. So an online news website store information about news articles. The fixed attributes can be in the author table, article ID, other ID, publication date, and article tables bio. So, however, the news website may also want to store additional information about each article that doesn't fit neatly into the predefined column. So, this could include a list of relevant keywords for better searchability, links to related article, social media reaction, and geolocation data if the article is about a specific location. So there is some limitation of this also. And now talking about that is last one, associative data model. So an associative data model is a model with the data divided into two components, entity and association. So everything with an independent existence is termed as entity, and the relation between the entities called a connection or a association. So the data is further divided into items and link. Item means an item contains a name and identifier, and link, the link compromises the source, verb, subject, and unique identifier. So type of now discussing about flat data model. So a flat data model is a very basic way of storing data in database management system. It is just like simple spreadsheet with the rows and column. And you can take example of Excel. So Excel is a basically example of flat uh, data model. And we have last one, that is construct data model. So the construct data model is a collection of a variety of model. It comprises of models such as network model, object-oriented model, data relational model. Okay, so with this model, we can accomplish various tasks that not achievable using just one model. Now, talking about data abstraction. So, data abstraction refer to the process of hiding unwanted detail from the user. So basically, just I'm taking example. Suppose if we want to access any mail from our Gmail, then we don't know whether that data is physically stored or what data model has been used to store that data. We are not concerned about these things. We are only concerned with our emails. So the information like this, location of data and data model are unwanted. So this is done by data abstraction, and there are mainly three levels of data abstraction, and we divide it into three levels in order to achieve data independence. So as we discussed, data independence means user and data should not directly interact with each other, and the user should be at a different level and the data should be present at some other level. By doing so, data independence can be achieved. So currently we are discussing data abstraction. So there are three level of data abstraction. One is view level, second is conceptual level, and third is physical level. So uh, in this diagram here you can see this is view level, this conceptual level, and this is physical schema. So talking about view, so basically view means when you are opening any website, just I'm taking example of Facebook. If you are opening Facebook, what do we see? We see the message, all the things we are seeing. So basically that is example of view level. So this level tells the application about how the data should be shown to user, means how user is going to see the data. So example, you can take if we have a login ID and password in a university system, then as a student we can view our marks, attendance and fee structure. But the faculty of university will have a different view. So he will have option like salary, edit marks of a student, inter attendance of the student. So both the student and faculty have a different view. Now talking about conceptual level or logical level, we can say that this is basically middle level, and in simple language you can this is level where mostly coding used to be done. So this level tells how the data is actually stored and structured. We have a different data models by which we can store the data, and suppose let us take example where we use the relational model for storing the data. We have to store the data of a student. The column in the student table will have a student name, age, mail ID, roll number. So we have to define all these at the time of level while we are creating the database. So overall, we can say that we are creating a blueprint of a data at the conceptual level. Now, physical level means here we are talking about internal schema, and that is just like a database where we used to store the data. So, so the physical level tells that where the data is actually stored. Is tell the actual location of data that is being stored by the user. So the database administrator decide that which data should be kept at which particular disk or drive, how the data has to be fragmented, where it has to be stored, and they decide if the data has to be centralized or distributed. So we see the data in the form of table at the view level. The data here is actually stored in form of file only. So here just I have taken example of login form. So basically this is example of view level because here we are seeing only a form. Here we can see here we are creating a connection in logical level, so we can access data from the database, and this is basically coding of a conceptual level or logical level you can say, because here all the rules has been defined ki how your data is going to be stored, how we get the message, and this is last level, that is physical schema, where we have created database and table. So basically this information and this information we doesn't see, only what we see this. So this is process of abstraction to hide conceptual level and physical level. Now Last one topic is data independence. So basically, data independence is a property of a database that allows the user or database administrator to change the schema at one level without affecting the data or schema at another level. Means in this, if you want to change, if you want to user want to make changes here, so basically, it will not affect conceptual level and physical level. So basically, this is process of data independence. If user is just changing at this level, it will not affect at conceptual level and stable level, external level. So this is concept of data independence. Okay. So basically, the purpose of data independence is to enhance the security of the system, save time and reduces cost needed once the information is changed or altered. And what is also advantage at it, at it at any time, at least various person works. Okay, one person can work on this level, one person can work on this level, one person can work on this level. So basically it will save time. And based on the data abstraction, there are two level of data independence. One is physical level data independence, and second is logical level. So now, what is physical data independence? So physical data independence can be defined as the ability to change the physical level without affecting the logical or conceptual level. And means we are making changes here without affecting this and this. Physical data independence gives us the freedom to modify the storage device, file structure, location of the database, and without changing the definition of consensual or view level. So, example, if we take the database in banking system, and we want to scale up the database by changing the storage size and also want to change the file structure, we can do it without affecting any functionality of logical schema. Logical data independence is a property of database that can be used to change the logic behind the logical level without affecting the others layer. Means here we can make changes without affecting the external level and physical level. So logical data independence is usually required to changing the conceptual schema without having to change the external schema or application program. It allows us to make changes in a conceptual structure like coding, modifying and deleting attributes in the database. Okay. Now, what is basically difference between physical level and logical level independence? So, physical data independence is used to change the internal schema without requiring a change in the logical schema. And logical data independence is making sure that if you add any new field or delete any existing field, we do not need to change the application program. And physical data independence is easy to attain in the comparison to logical data independence, and it is difficult to attain logical data independence compared to physical data independence. And physical data independence provides feasibility if we want to shift the database or want to change the file organization structure. And logical data independence help us to change the data definition and the structure of data without having changes in the physical schema. And physical data independence deal with the internal structure of a schema, and logical data independence deal with the conceptual schema. So this is all about in this video. We have discussed various data model, and now we have discussed data abstraction, and we have already also discussed data independence. So if you have any question regarding this topic, so definitely you can post a comment, and I will happy to reply the answers up for those questions. So this is all about in this video. So thank you for watching this. Thank you.